All right, so uses and abuses of percentages. So when I say abuses, I really just mean misunderstandings. And sometimes people use statistics to purposely misrepresent something that they're trying to show. And it's very easy to get people confused with percentages. And so that would be like an abuse of percentages. All right, so let's start with a basic understanding of what percent means. Percent really means per 100 or out of 100 divided by 100. So we use the percent symbol as shorthand for percent. So when we say 50%, what we mean is 50 out of 100, or equivalently the proportion 0.5, right? But that's already an area of confusion because people will sometimes just flip-flop between talking about percentages and as proportions. So there's a very big difference between 50% and 0.5%. There's a huge difference between those two. Those are not equal, right? But if I get rid of the percent here, then those are equal. Okay. So more generally, anytime we want to find the percent, capital P, we take capital P and put it out of 100. That means 100% equals 1 as a proportion. 200% equals 2 as a proportion. 350% equals 3.5 as a proportion. It can make sense to talk about percents larger than 100 depending on the context of the situation, and we're going to see some of those today. Sometimes it doesn't make any sense to talk about percentages larger than 100. But if you're talking about enlarging something or getting a raise in salary, so you could say, I got a 200% raise in my salary. That basically means you're making 3 times what you originally made. And we'll talk about that later. So equivalent fractions, right? So 25%, if we want to convert it to a common fraction, we get rid of the percent sign and we instead divide by 100. So 25% equals 1/4, which is 0.25. It's not 0.25%. That's very different than 25%. That's much less than 25%. It's just 0.25. And so that's a common fraction. And then if you want an actual decimal like I did here, you would actually just divide out the fraction, which you could just do in your calculator. Okay, I want to make sure I'm pacing it okay. Please give me a green check if you're with me so far and ready to go to the next slide. All right, if you want to go from decimal to percentage, just multiply by 100 and then insert the percent symbol, right? So 0.43 times 100 is just 43, and then we add the percent symbol. To go from fraction, first divide it out in your calculator to get to a decimal, then do the same steps we just did. Multiply by 100, add the percent sign. I'm sure this was hopefully some basic arithmetic you were already relatively familiar with. Maybe you didn't have kind of a formal demonstration yet, but all right, so there are 3 ways that we talk about using percentages. So that's as fractions. So like I talk about a total number of something, and then I'm talking about a fraction of that population. So 2.6% of the 13,000 people lost their jobs. Oh no, not of the None of the 13,000. That's how many lost their jobs. So 13,000 people, which was 2.6% of the workforce, lost their jobs. So they don't tell us what the total workforce was. But 13,000 out of that total workforce gives us the fraction 2.6%. So 13,000 out of the workforce gives us 2.6%. So that's as a fraction. So we could describe change using percentages. So we could say a certain stock, in this case Citigroup, fell 15% last week to a price of $44.25. And then we can use them for comparisons. And this is going to be the one that it makes some sense to have percentages above 100. So for comparisons, I could say the advanced battery lasts 125% longer than the standard one, but it also costs 200% more. Okay. All right. So we're going to jump right into an example. An opinion poll finds that 64% of the 1,069 people surveyed said that the president is doing a good job. How many said the president is doing a good job? All right. So the way we're going to parse this is by looking at the language. Of is generally indicative of multiplication. So we're going to say that 64% of 1,069 people. And so to be able to multiply that out, we would actually want to convert the 64% into a decimal. So 64% is really 0.64 times 1,069. And then that we can pop into our calculator. And so I get 684.16. You can't really have 1.16 of a person, so they probably rounded it off to 64. So I'm going to round it to 684, about 684. We're going to make sure we add units here because there is context. People. All right, and that's it. So that first example was using percentages as a fraction of the whole. All right, so give me a green check once you're good with that example. If you have questions, go ahead and ask in the chat or unmute and ask. All right, so going back, the other way we can describe change is, we can use percentages is to describe change and for comparisons. So to describe change, we have two ways of talking about change, and I do want you to write down these formulas. So absolute change describes the actual increase or decrease from what we call a reference value. And the way you find absolute change is you take your new value and you subtract your reference value. And that will have units of whatever it is you're talking about, whatever your population that you're looking at is. Okay. A relative change is always a percent. Percents don't have any units. And so what you do to find a relative change is you take your absolute change and you divide by the reference value. So to simplify that even more, we have new value minus reference value divided by reference value, and then we'll convert it to a percent. So again, make sure you get these formulas down. Give me a green check when you're done with this, and we'll do an example of absolute change versus relative change. So diversified portfolio is just a collection of multiple different stocks, and it increases in value from $1,500 to $2,250. First thing I want is absolute change. So I would just take my new value, which is my $2,250. I would subtract my reference value, which is my $1,500. And again, my units would then just be in units of whatever the original data is in. So in this case, it's dollars. So 2250 minus 1500 is just $750. Important to keep in mind here that my reference value is the 1500, because now we're going to see my relative change, which is going to be a percent. If your relative change is positive, it's growth, you're going to expect it to be a positive percentage. If it's negative, you'll expect it to be a negative percentage, so if it depreciates in value. All right, so we have our absolute change, which was $750, divided by our reference value, which was $1,500. And so notice that by unit analysis, the units cancel out. This is leaving us with a percent. 750 divided by 1,500 is just 0.5. And remember, we want to write it as a percent, so times 100%. So we get a relative increase, since it's positive, of 50%. All right, let's keep going. Let's look at another example. You bought a computer 3 years ago for $1,000, and today it's only worth $300. Describe the absolute and relative change in the computer's value. So we're going to take the original price. This is going to be our reference value. Right? So my absolute change, I take my new value and subtract my reference value. So it's going to be $300. Oh no. My Apple Pencil ran out of batteries. I got to use my finger. My handwriting's about to get much worse for a minute while this charges. So I'm going to take my new value, which is $300. I'm going to subtract my reference value, which is $1,000. That's going to give me my absolute change, which will be negative $700. So another way of saying that is that our computer depreciated by $700. So for the relative change, we're going to take the absolute change, which is the negative $700. We're going to divide it by that reference value, which was the $1,000, the original price. So negative 700 divided by 1,000 gives us negative 0.7. And we'll again convert it to percent, so times 100% is just going to be negative 70%. Right? So another way of saying that is that all the negative tells us is that it's depreciating in value. So our computer depreciated in value by 70% over the course of 3 years. All right, that was 2 examples. Just want to make sure everybody's caught up. Give me a green check when you're good to go. Similar to our last set of formulas, which was absolute change and relative change. And that's because it is almost the exact same, except that with change, we're generally talking about some change over time. But now we're going to be talking about absolute difference and relative difference. So the formulas, if you look at these, they are exactly the same, right? Almost. The absolute difference is a compared value minus a reference value. And the relative difference is you take that absolute difference and you divide by the reference value. So you still have a reference value, but notice the language is slightly different, right? Instead of saying new value, which is indicative of a change over time, they're talking about a comparison. So these values could be happening at the same time, but you're using one as a reference and the other as a comparison value, okay? And that it's a little bit nuanced how to decide which is the reference value and which is the comparison value. So I think the example we're going to do is like looking at two car prices. So if you're car shopping, you're going to be looking at multiple cars or two cars, let's say, that have different prices at the same time. So there's no new value and reference value. You're going to compare one to the other. So one's you're going to be your reference and the other's going to be your comparison. And it's really important that you're able to discern by the context of the prompt which is which. So again, please go ahead and give me a green check when you're done with this slide. We're going to be looking at average full-time pay for wage earners in South Dakota versus New York. All right, so one way to make the decision, the first thing you want to do is read through your problem and then make the decision on what is your reference value and what is your compared value. So in this case, it said New York ranked first in average pay at about $60,300 per person, and South Dakota ranked last at $32,800 per person. Compare average pay in South Dakota to that in New York, both in absolute relative terms. So since we're comparing to that in New York, right? The words to that are telling me what I'm comparing to. The thing I'm comparing to is always my reference value. So this is my reference. Once you've decided on your reference value, the other one is by default your compared value. So South Dakota wages are my compared value. Okay. All right. So we can go ahead and plug those. Let's do absolute first. So I'll say my absolute difference so remember that's just going to be your compared value minus your reference value. So it's going to be my South Dakota minus my New York. So it's going to be my 32,800 minus my 60,300. And subtracting those out, we're going to have units of dollars. We're going to get negative $27,500. All right, so then we'll look at relative difference. So all we're going to do is take that absolute difference, that negative 27,500, and again, we're going to divide by our reference value. Remember, the New York is our reference value. So I'm going to divide by the 60,300. It's going to give me negative 0.456. We're going to multiply that by 100%. And so we're going to get negative 45.6%. And so the way we can interpret this is pay in South Dakota is about 46% less than that in New York, okay? So let's talk about of versus more than. And so what you really want to write down, I'll underline. If our new or compared value is p% more than the reference value, that means it is 100 plus p% of the reference value. If the new or compared value is p% less than the reference value, that means it is 100 minus p% of the reference value. It's really important because if we can change from the verbiage of more than to of, it's going to be much easier for us to make calculations because we know what to do with of. Of is an indicator of multiplication, right? So if we can get it to be in terms of, we can convert our percent to a decimal, and then we can just multiply that decimal by our reference value. All right? So again, give me a green check when you're good with this slide. We'll jump into a couple of examples. All right, I'm going to move forward. All right, so Carol earns 50% more than William. How many times larger is her income than his? So we're comparing Carol's income to William's. Therefore, William is my reference value. They don't actually tell us how much William makes. So let's just call his salary, let's call it capital W. And what I'd like is to convert from the statement more than to of. So going back, if it's p% more than the reference value, it's 100 plus p% of the reference value. So in this case, what percent of William's salary is Carol's? What percent of, in the chat, what percent of William's salary, Carol, is what percent of W? Good. Thanks, Colin. 150. So we would just do 50, that, or 100 rather, sorry, plus our p-value, so plus 50. So she's 150% of W. So of indicates multiply, so 150% times W. But of course, if we want to multiply, we got to convert 150% to a decimal. So what's 150% as a decimal? Well, percent means out of 100. So it's 1.5 times W. So you can see here, if I write it out this way, Carol's salary equals 1.5 times William's salary. So Carol's salary is 1.5 times as much times more than Williams. All right, excellent. So let's move forward there. Let's try one that's less than. So 25% off sale. How does this item's sale price compare to its original pricing? So 25% off would be 25% in that case less than the reference value, right? The reference value being the original price. So now we want to use this, 100 minus P. So if I'm doing 25% off, that means, again, 25% less than the original price. And I'm just going to call that original price P. So what I want to do is know what percent of the original price is it. So again, in the chat, if you're using that formula, what percent of P would it be? Good, 75%, because we would do 100 minus that value, so minus the 25. So it's 75% of P. Or if I want to convert that to a decimal, that's 0.75 times the original price. So to answer their question, they kind of say just vaguely, how does it compare to the original price? You could answer just by saying it's 75% of the original price. Or you could say it's 0.75 times the original price. That makes either one of those is totally acceptable to me. Okay. So I'm now going to kind of go through just a few key points of understanding and some abuses that can happen in percentages. So percentages of percentages. When we talk about percentage points, that's an absolute change in percentage. When we use the percent sign or the word percent, they're talking about relative change or a difference. And I'll give you an example from this. If a bank increases its interest rate from 3% to 4% for like a savings account, the interest rate would be how much they pay you annually on the money that you've deposited, right? So if it was 3% and they increase it to 4%, now you're going to be earning more on whatever the money you have deposited. It increased by 1 percentage point. That's the absolute change, right? So that's just, if I do 4% minus 3%, it definitely just increased by a full percent in absolute terms. Anytime you see the word point, they're talking about absolute change. But if we look at this from a relative perspective, relatively, a change from 3% to 4% is much larger. And the way I would do that is I would do my new value minus my old value, so my absolute change, and then I would divide by my reference value, which in this case, my reference value is the old value, the 3%. And so if we do that, we end up with 1 over 3, or 0.33, or multiply that by 100%, that's a 33% increase. So we can look at that change in two ways. Absolutely, it increased by 1 percentage point. Relatively, that was an increase of 33%. Okay. All right, give me a green check if that makes sense. All right, this isn't anything new. This is just, we were kind of already doing this when we talked about converting from P% more than to P% of, and converting from P% less than to P% of. But I will have you write down this. So write down what's in blue, and then write down this formula. If you want to shorten things up, you can just write compared value of CV, and then reference value as RV. And then also write down if compared value is less than the reference value, then this is the formula that we're going to use for that scenario. Again, I'll clear out the green checks. Give me a green check when you have those formulas written down. So you purchase a shirt with a labeled pre-tax price of $21. The local sales tax rate is 6%. What is your final cost including tax? All right, so the final cost is the cost of the item. So it's its labeled price plus the sales tax. So for a tax rate of 6%, we're going to say the final cost is 5% more, or sorry, 6% more than the labeled price. So final cost is, we're going to be using then, since it's 6% more than the labeled price, I'm going to be using this formula. So it's going to be 100 plus P% times my reference value. So my compared value in this case is going to be my final cost, which is 100 plus 6% of my pre-tax price, which was $21. Okay, so that's 106% of $21. So convert percent to decimal, that's 1.06%, sorry, 1.06 times $21. And I get a final result of $22.26. Okay. So just some notes to think about. Abuses of percentages. If we talk about shifting reference value, something in a situation where you get a 10% pay cut, and then that's followed by a 10% pay raise. Well, let's say you make $100 a day, right? A 10% pay cut means you would be making 10% less than you normally would. So to change from less than to of, that means you would be 100 minus 10% of your original. So 100 minus 10% of the original, of means multiply. So that'd be 90% of the original $100. Converting 90% to a decimal, that's 90 times 100. 0.9 times 100 rather, which means I'm now making $90 a day after my 10% pay cut. Now let's look at following that, right? The pandemic's over and they're willing to give us a raise again. So what if they give us a 10% pay raise back? Well, now we're only making $90. So that's 10% more than what I'm making. Remember that more than says we add. So it'd be 100 plus 10% of my current value. So that one's going to be 110% times 90. And that's 1.1 times 90. Which equals $99. Am I back to what I used to make? No, right? We originally made $100 a day. And now we got a 10% pay cut followed by a 10% pay raise. We're down to $99 a day. And it's because my reference value shifts from being 100 in the first case to only being 90 in the second. So 10% of 100 is different than 10% of 90. That's one thing to pay close attention to. Less than nothing. So it only makes sense when we talk about percentages that are more than 100 when we're using percentages as a means for comparison. If we're using percentages as a fraction of something, it can't be more than 100. So if I'm going to decrease my caloric intake by 150% to lose weight, that means you're going to be eating less than nothing. Now, in this case, you could argue, yeah, I'm not going to eat anything, and I'm also going to exercise, which is technically burning calories. You could kind of push it on this one. But my original point stands. Generally, when you're talking about percentages as a fraction of something, you can't use values larger than 100%, right? And then also, it doesn't make sense to average percentages in most cases. If 70% of the boys and 60% of the girls in a class voted to go to a water park, then 65% of the students in the class wanted to go to the water park. That would only be true, if it's the exact same number of boys and girls. That's the only time it makes sense to average percentages, is if you know the populations are the exact same size in both cases, in which case it's fine to average percentages. Otherwise, you cannot. Think about our class as an example, right? If we have like 2 boys in our class, or 3 boys, wait, 4 boys, okay. Anyways, let me give you an example that tends to be common at ASA. If we have 2 boys in the class and 28 girls in the class, and 70% of the boys, or that doesn't make sense with 2 boys. If 50% of the boys say they want to go to the water park, right? But 60% of the girls say they want to go to the water park. That's 1 boy versus like 16 girls. So no, it doesn't make sense to average percentages in that case. All right, I already kind of did some of these examples, so I'm going to leave that. Well, we'll do some warm-up examples of these next time, just so that it's been a little bit of a marathon here. All right, so we're going to stop.